So good morning, everybody. Welcome to the third webinar of the series Artificial Intelligence Methods and Applications. As you know, this is a German-Italian series where an expert in a certain AI topic, in this case from Italy, and an expert from Germany have a talk of about 30-40 minutes. And then at the end, we can have we can take questions, and the question must be written and only written on the right-hand side. In the box, you have a field called domande or questions. So welcome everybody. We have mostly an Italian audience today of CNR researchers, but we also have a few colleagues from embassies from Mexico and France, I saw. Then some guests from a guest from Israel, I saw. And so we're happy about that. I forget it normally, but it's it should be clear that if the CNR researchers who receive this invitation, who they think are interested in any other institution, national or not, they can do it. And the same for the German speakers. Okay, so as I said, this is the third webinar. We'll have a fourth webinar in 2 weeks. Normally, this is the rhythm, every 2 weeks on Wednesday from 10 to 12. The next speakers will be Giuseppe De Pietro and Antonio Krüger from the German Institute for Artificial Intelligence. They will have a more, let's say, a webinar dedicated to policies, so a bit more, not a single topic, but more a political, let's say, topic about big programs in Italy and Germany. Today is dedicated to AI for cultural heritage. We are very happy and grateful for having Giuseppe Amato from the Institute of Information Science and Technologies of CNR and Andreas MAIER from the Pattern Recognition Lab at the University of Erlangen-Nuremberg. So now it's my pleasure to give the floor to my co-host, Vincenzo Fiorentini, Professor Vincenzo Fiorentini, who is the science attaché in the Italian embassy in Berlin. He will give some introductory words, and then we'll introduce directly the first speaker, who is Giuseppe Amato. So please, Vincenzo.
Thank you, Matteo. Good morning, everybody. As Matteo mentioned, I'm one of the two science attachés at the Italian embassy in Berlin. And I apologize in advance because it may be I will not be able to attend the whole event because of a concurrent, was being summoned to a concurrent BTC starting in a few minutes. So sorry about that. So of course I bring the greetings from the embassy, and we're of course happy of this continued collaboration with CNR on this webinar. It's the second series. And we hope to further this in the future, of course. So today we have Giuseppe Amato and Andreas MAIER as speakers, and the first speaker, just in alphabetic order, is Giuseppe Amato. Giuseppe Amato has a PhD in computer science from Dortmund, Germany, so he has ties to Germany other than, let's say, a geographical neighborhood. And he's a research director at CNR Institute, the Institute for Information Technology in Pisa. And he's the leader of a laboratory that is called AIMH, if you look for it on Google, which is Artificial Intelligence for Multimedia and Humanities. And I mean, he works in artificial intelligence, content-based retrieval, multimedia, and so on, in particular, connected with cultural heritage. And the title of his talk is Artificial Intelligence and Multimedia Information Retrieval Applied to Cultural Heritage. Please, Giuseppe, thank you.
Good morning to everybody. 1 second. I hope you see my slide.
We do.
Okay, perfect. Okay, thanks a lot for the introduction, and thanks also for inviting me to give this webinar today. I hope that my talk will meet your expectation. As just introduced, I'm going to talk about artificial intelligence and multimedia information retrieval applied to the cultural heritage domain. Specifically, I'm going to tell you something about the experience that we did in my lab in the last, let's say, 15 years on applying multimedia information retrieval, computer vision, and artificial intelligence to the cultural heritage domain. Just a few words about the overall activities that we carry out in the lab. We are working on basically on 4 pillars of activities. The first one is computer vision and deep learning, and these activities led by Fabrizio Falchi, artificial intelligence and applied to human language, applied to text, and this is done by Fabrizio Sebastiani, is coordinated by Fabrizio Sebastiani. Artificial intelligence and digital humanities, and this is led by Carlo Mighini. Last but not least, artificial intelligence and multimedia information retrieval, led by Claudio Gennaro. We are about 35 people in the lab, 15 researchers, 7 research assistants, and 4 of them are doing the PhD, 6 external PhD students, plus a technician and 1 person that deal with the administration of the lab itself. Okay, let's go a bit more toward the technical issues. In a few words, one of the main topics that we are trying to address is to do image search, image retrieval on a very large scale. I try to summarize in this picture what is the main aim of this research. If you have a single picture, in a picture there is a lot of small details that are informative. Typically we say that 1 picture is worth 1,000 words, but if you have 1 billion pictures without descriptions of the pictures themselves, typically you are lost. For instance, if you want to search the picture on the left in a database containing 1 billion pictures, this is not trivial. Our main research direction is try to address this problem, how to search in huge databases of images with no annotations associated with images, and specifically with applications also to cultural heritage, and we will see some specific examples in this direction. Just to start with a very preliminary demonstration. Let me see if you can see. Do you see my web browser? I hope. This is a system that we built now, I think something like 15 years ago. It is an image search engine. The database contains 100 million images, and we can visually search the images in the database online in a fraction of a second. And this system does not run on cloud, on huge servers like Google or Amazon. It runs on a small computer that we have here. So the issue is twofold. Accuracy. So in this example, I search for a cat and I want to retrieve cats, but efficiency as well. So I searched for cats in a database containing 100 million of images in a fraction of a second, and I was also able to tag the query. In this cases, it was automatically tagged cat, kitten, pet, etc., etc. But this was, let's say, something like 15 years ago. But this is the starting point. Okay, if you have a database of images, how can you search for images in the database? If the images in your database are associated with tags, with keyword, with captions, typically you can use text search engines to retrieve for them. So for instance, if your picture is associated with, consider this picture with the Hotel of Invalides. If it is tagged as Hotel des Invalides, Paris Museum Grasse, you can use these keywords to retrieve those pictures. And the descriptions of the images can be done manually, but they can also be done automatically by using automatic tagging or automatic captioning solutions. However, if you use those techniques, you might have some problem, because on one side you can use text search techniques, which are well-established techniques. All of us, I think, every day we use text search techniques. For instance, if you search Google, you are using a text search engine. However, it is not trivial to annotate very large data sets, and especially if you want to re-annotate, because, for instance, you have a new technique to produce better caption or better annotation, you have to redo everything from scratch. And if your database of images is huge, if you have 1 billion images and you want to re-index everything from scratch, it is not such easy to be done. So even if you can use text search to retrieve images, once you have generated annotations for the images, this is typically not the best solution. You want to find other alternatives. One alternative is to get rid of the text description and go directly into the content of the image. Even if the image is not described by text, the image has a lot of information, which, if correctly described, correctly represented, can be used to retrieve the image themselves. Typically, you extract semantically relevant features from the images, and you can use content-based image retrieval solutions to retrieve images. In that case, typically you use another image as a query. In my example here, and then we will move to cultural heritage, don't worry. In my example here, I have a tree with yellow leaves. The query image is processed, and we extract visual features from the image, and the visual features are matched against the visual features of the images in the database. In such a way, you retrieve visually or semantically similar images from the database with respect to your query. In order to do that, say in a very accurate way, there is a lot of artificial intelligence. Just to give you a glimpse without being too technical, nowadays the most popular techniques for addressing those problems is using neural networks, like, for instance, convolutional neural networks or vision transformers or other techniques. But okay, at the basis, you have neural networks. What happens is that by using neural networks, what happens is that if you provide the neural network with two semantically similar images, the activation values that you can read from the neural network are similar as well. So what you do typically is the following. Suppose you train your neural network by providing the neural network with images associated with tags. For instance, cat associated with the word cat, a dog associated with the word or the tag dog, a car with the tag car. And the neural network learn how to recognize if in a picture there is a cat, a dog, or a car, or whatever. After the neural network has been trained, what happens is that if you provide the neural network with an image with two semantically similar images, so a cat and another cat, the activation levels read inside the neural network are similar as well. So in order to decide that two images are semantically related, instead of looking at the pixel of the image itself, we can simply look at the activation levels of the neurons inside the neural network. And this can be represented as vectors in a space. So you basically search for points in the space that are close together. So if the two input images are similar, the vectors are similar, let's say the vectors are one close to the other in the space, and you can use this property to search in large database. So the global picture is the following. You start you start from visual features, either extracted from another image or obtained by using text, and we will see how to do that. And then you use the visual features, so the vector that you see here, as a query to the database in order to retrieve similar vectors which are associated with similar images, and you retrieve your image. This was the example that you saw before at the beginning, where in the brief demo that I gave to you. The challenge is that we want to do it very efficiently in addition to very accurately. So just to give you an idea, in the demo that I gave you before, I searched in a database containing 100 million images. And if you print one by one the 100 million pictures and you put one picture on top of the other, you end up with a pillar high 10 kilometers. So we were able to search in a fraction of a second in a pillar of 10 kilometers of images. So this was the challenge. There are various applications to those techniques, and today we are focused on application to the cultural heritage domain specifically. We have been running a certain number of projects, most of them European projects or even national projects, where we use computer vision or artificial intelligence to the cultural heritage domain. And now today I'm going to tell you some highlights that we obtained during the past 15 years. Let me start from a search engine for painting. Let me try to also run a demo in this case. Okay. Yeah, okay. You can ask for a random query to start from. So suppose I choose this picture. I click on the picture and I retrieve other pictures, in this case portraits of a man, from the database that was indexed by this search engine. Let me try something different. Here I have a woman sitting, and I retrieve, let's say, semantically related painting to my query. Okay, this was a sequence of screenshot of the same demo. So suppose I take it, I use a painting containing a building as a query. This is the result that I obtained. And this search engine currently indexes 100,000 images containing painting. And you can also use natural images for your query. So for instance, if you want to search for painting containing a bridge, you can, and if you have a picture of a bridge, you can use your picture as a query, and this is what you obtain, for instance. Okay, so you find a painting containing a similar bridge from the database. Okay, the demo that I just gave to you was about using say image search engine, but you can apply those techniques also for using your mobile phone to search for information about something that it is of your interest. In 2009, so let's say 14 years ago, we obtained this grant. It was called Visito Tuscany. It was a project funded by the Tuscany region using European funds. And we created, I think, one of the first application in the world where you could use your mobile phone to search for information visually. So you simply point your mobile phone toward a monument, a building, a work of art, and you obtain information about that building. Now it looks to be, say, more normal, but consider that this project ran in 2009, when the smartphone were still, say, a dream for most of us. I mean, smartphones were not so common among people. Before going to show you something in this direction, just some provocation. At the beginning, when I told people we developed this application that allows you to search for information visually using your mobile phone, typically most people say, but why do you need that? Can you use text to search for the same information? In fact, suppose you are in front of the Pisa Leaning Tower. By the way, I'm living in Pisa and I'm talking from Pisa right now, so this is why I'm using the Pisa Leaning Tower. Suppose you are in front of the Pisa Leaning Tower. If you want to get information about the Pisa Leaning Tower, you can simply search in Google using Pisa Leaning Tower, so it is easy. But okay, this is a bit misleading. Suppose you are in front of this, okay? You do not have any clue on how to search for information about this. I mean, unless some of you is a hard historian and knows exactly what is this fountain. Okay, you have no clue on how to search for information on this, but the information is there, is in the real object, is in the visual information in front of you. In this case, for instance, being able to visually search by using your mobile phone might be very useful. Another example, I'm going to tell you something more about this project, but some years ago we were involved in European projects to build a repository for Roman and Greek epigraphies, so inscriptions. And also in that case, we wanted to provide users with the possibility of searching visually for epigraphs. And of course, if you want to search for information about these epigraphs, you can use the text in the inscription itself. So in this case, it is trivial, but there are some cases like this. Okay, there is no possibility of searching for information by using text. For what concerns this fragment of an epigraph, which is, let's say, relevant from the point of view of the archaeologist. So I hope I convinced you that visual search from mobile phone is useful. Let me give you an example of this project that we ran in 2009. The idea was the following. Okay, you simply point your mobile phone toward the subject of your interest. In this case, by the way, this is the Scuola, it is the Palazzo della Carovana here in Pisa, which is the headquarters of the Scuola Normale Superiore, the École Normale Supérieure here in Italy. By taking a picture, the building is recognized and you get description of the Palazzo della Carovana. Well, 2009, as I told you, everything was running on the mobile phone. At that time, the time required to go from the picture taken by the mobile phone to the instant where you get information about the picture that you took was something like between 6 and 10 seconds. So the person had to stay 6 seconds waiting for receiving information about that monument. But that was the, let's say, very pioneering work in this direction. Later on, we improved a lot this technique, and nowadays we are able to give, let's say, almost real-time response. So you simply point your mobile phone and you instantaneously get information. And with this, let's say, advanced solution, we also had collaborations with industry. By the way, we also built a spin-off using this technique. And just to give you some real application that we built by using these advanced techniques, a nice application that we built was a kind of city treasure hunt. The idea was to have people going around a seat of art, following an itinerary by playing a visual treasure hunt. So by using their mobile phone, they received a riddle that they had to solve. But in order to show that they were able to solve the riddle, they simply had to point with their mobile phone the subject of the riddle. So, for instance, if the subject of the riddle was the Pisa-Leaning Tower, they had to go in front of the Pisa-Leaning Tower and take a picture of the Pisa-Leaning Tower. Automatically, the picture was recognized, and in case it was a success, they received another riddle, so they followed an itinerary in the city. And this was particularly appreciated, for instance, by school visiting seat of art. So the students were able to, let's say, get information about the art history in playing a game. These videos that I'm going to run, I hope it works, is an application to a museum setting. This is the Museo Piaggio, is the museum where the Piaggio motorbike are produced. And again, you simply point the mobile phone toward an object in the museum, the object is recognized, and you get information about the recognized object. In this case, the Vespa produced by Piaggio. Similarly, we also made an application for the Pinacoteca di Brera in Milan, and the paradigm is again the same. You go in front of a painting, you point your mobile phone toward the painting, it is recognized, and you get information about the painting in front of you. So as an alternative to the audio guide, when you use the audio guide, typically you have to type the number associated with the painting, or say point to a QR code. In this case, you simply point directly to the work of art itself. I mentioned before this project we had this European project on epigraphies. The name of the project was EAGLE, which stands for Europeana Network of Ancient Greek and Latin Epigraphy. And the aim was to build a repository, European repositories for all information related to Latin and Greek epigraphy. So once the repository has been built, it has been possible to search the repository for information about the epigraphies in a traditional way, for instance, by using metadata associated with the epigraphies. In addition, we provide the possibility of searching for the same information simply by pointing the mobile phone to the epigraphy. Currently, we have 1 million images of inscriptions in the system, and they are all visually recognizable. The paradigm is the usual. You point to the inscription or the object of art, the work of art where the inscription is contained, and you are redirected to the page of the repository describing that inscription. Here again, video demo. So here we are in front of the inscription. We point the inscription. It is recognized, and you have access to the description produced by the archaeologists or about the inscription itself. Okay, this project was running in 2014, if I'm not wrong, and the technique that we used were basically computer vision techniques. So we use the so-called local handcraft features in order to decide that an image in the database was matching the image taken by the mobile phone. So the idea was to identify some key point in the two images, the one in the repository and the one coming from the mobile phone, and checking if that there was a spatial transformation that was able to match the set of point coming from one to the set of point coming from the other. If we were able to find that match, the the query was positive, so we were able to say we recognize the picture, and we triggered the action of retrieving the information from the repository, and all that computation was made on the mobile phone in real time. We are currently running a project still on the same path. This project is called Extension, and it is funded by ESA. By the way, we are at the end of the project. We're going to have the final review in a couple of weeks of this project. And what we did is to work on the monuments and work of art in L'Aquila. You know, L'Aquila was a city in Italy that suffered from earthquakes some years ago. Most of the buildings in L'Aquila were restored. So the project has the objective to give access to everybody to the information about all monuments in L'Aquila, also by using a mobile phone. We identified all the monuments, relevant monuments in L'Aquila. I here give just some few examples, and we, in order to recognize the objects, the monuments, the picture of monuments taken by the mobile phone, we use at the same time a combination of computer vision and artificial intelligence. So we, as I said before, we take the picture is analyzed, and at the same time we extract the local features in order to match this cloud of points, as I said before, but we also use artificial intelligence to extract global information, semantic information about the objects, to confirm or to, let's say, revise the decision taken by the computer vision part. So the picture coming from the mobile phone is compared against the pictures in the database, and when the object is recognized, the information is given back to the mobile phone that provides you with information to related to the work of art that you have at your hand. There are also additional possibilities for this technique. I mean, using your mobile phone, for instance, you can build dynamic books where the book, you know, it is a static object. Okay, once the book is printed, the information cannot be changed. But by using your mobile phone and pointing with your phone to pages of the book, you can provide users with additional information, updated information. Or, for instance, suppose you have a book containing pictures of painting of a specific museum. You can suggest the user to buy the ticket for the museum directly from the book that they have in your hand. And the next step could be to move to augmented reality. So no longer, or let's say not only the mobile phone, but you might use smart glasses, and you go around the city and with your smart glasses and get information about the work of art directly without using your mobile phone. Okay, after this, let's say, description of the activities that we have been doing using artificial intelligence, computer vision, mobile phone for cultural heritage, let me say something still related to cultural heritage, but going in a completely different direction. We currently have an active collaboration with the Carabinieri, working on stolen work of art. Is the Nucleo Carabinieri per la tutela dei beni culturali. Is the group of Carabinieri working on preserving cultural heritage. What they have is a huge database containing pictures of stolen work of art. Sometimes these stolen work of art are sold in antiquity markets in the streets. So, and typically it is not easy to immediately recognize even for investigators that that specific object is a stolen work of art. So what we did is, again, a system by using your mobile phone where you take a picture of the object that you find in the market, or even in a, let's say, private collection, and check if it is one of the objects contained in the database of the Carabinieri, in order to possibly confirm and, let's say, persecute the person that has stolen or is selling the stolen work of art. And now, last couple of minutes, I think I still have a couple of minutes, right?
Yeah, you have yeah, a couple of minutes, right?
Yeah. I just need a couple of minutes to tell you the latest activity on which we are currently working. We are currently working in a system which is called Visione. Visione is a system for efficient content-based retrieval on a large scale, which somehow, let's say, collect together all techniques on which we have been working in the past years. And it allows you to search for videos by using various searching modalities, ranging from text search to objects contained in videos, to relationships between objects in videos, or visual similarity, searching for videos containing frames semantically similar to other images. So it is a very complex system where several of the tools that we have been developing in the last year converged to form one single system. I have a brief video.
We present our Visione system, a tool for effective video search on large-scale collections. It implements keyframe search by positioning the desired objects in a canvas. It is also possible to limit the number of instances of a particular object. It supports natural language queries for searching individual keyframes or full shots. The found shots can be easily previewed with a simple mouse right-click. The novel speech-to-text functionality provides an easier way for entering the description. Visione supports temporal queries by enabling the secondary search tools in the bottom left part of the interface. The results are grouped by video for a better browsing experience. The system supports different cross-modal search models, 2 clip-based models, and the novel Aladdin model. By default, all the 3 systems are employed for each textual query. The video can be played from the selected keyframe. The keyframes from the selected video can be easily browsed. The system supports instance and semantic shot similarities for finding similar keyframes. Finally, multiple keyframes can be selected and submitted.
I hope you were able not only to see the video, but also to listen to the description of the system. I give you a very quick demo also of this system. One of the, let's say, most effective search functionality in this system is the possibility of searching by using text. Let me point out, I think I did not specify this explicitly. All those videos are without metadata, so there is no text, there is no description of the videos, just the raw stream of frames of the video themselves. But I can search by using text those videos. So for instance, I can search for a video showing churches with a blue sky. Let me see if it works. I'm searching. Okay, so this is an example. So all those elements were retrieved without using metadata associated with videos, but directly analyzing the content of the video itself. As I said before, it is a combination of various components. So cross-modal search is not the only component of the system. You can search by asking for videos with specific objects or relationship between objects or colors or full text description as I just showed to you. Last 2 weeks, there was a presentation by Rita Cucchiara in this webinar series talking also about cross-modal search. So I just give you 2 words about cross-modal search. By the way, we did some work together with the lab of Rita Cucchiara on this topic. The idea is that if you have a picture and if you have a text, when they are analyzed, the descriptions of the 2 elements are represented in the same feature.
1 minute.
In the same latent space. And if you type a text, in order to retrieve images pertinent to your text, you simply translate it into a vector in the space, and you search for pictures whose representation is close to the picture itself. And here is a picture on how this is obtained. We have a neural network that is trained by providing it simultaneously with images and text describing the images, and the neural network learn how to mix the 2 things together. So I'm at the end. Let me just say that in February we participated to a competition on which is called Video Browser Showdown with this Vision Assistant, and we scored 2nd in the leaderboard. So we were very happy about that. By the way, we were scored 2nd considering the average of all ranks, but considering one specific task, which was the text to visual retrieval, we were 1st in that specific task. I'm at the end of my presentation. Of course, I'm happy to answer any questions in case you want to ask a question or have clarification on what I just said. Thanks again for being here.
Thank you, Giuseppe. So we stayed in time, 40 minutes. So I will just move to our 2nd speaker, who is Andreas MAIER. I give him the floor in between. All right. So I briefly introduce Professor Andreas MAIER. He studied computer science. He received a PhD from the University of Erlangen in 2009. His major research subject was medical signal processing in speech data. And during his PhD, he developed the first online speech intelligibility assessment tool with an acronym PEAKS that has been used to analyze over 4,000 patients and control subjects so far. I hear an echo. Let me see who echoes.
I muted my mic, so I probably not be responsible for this echo.
Okay. All right. And okay, now I think it's gone. Then he moved from the university. That's a very I think nice things which happens in Germany, because as you know, now he's back again in that university, but for a while he was away. So he was during his, let's say, postdoc years. From 2009 to 2010, he was in the Department of Radiology at Stanford University, so kind of going on with his work in ICT for medicine. And then he had also a stint in a company, no small one, in Siemens Healthcare, as innovation project manager. And there he was responsible, so in this couple of years he was there, for the reconstruction topics in the angiography and X-ray business unit. Then, as I was saying, he returned to the University of Erlangen-Nuremberg as head of the medical reconstruction group inside the pattern recognition lab. In 2015, so after just 3 years, he became professor and head of the pattern recognition lab itself. Since 2016, he's a member of the steering committee of the European Time Machine Consortium, and I believe he will tell us about that. Importantly, in 2018, he was awarded an ERC Synergy grant called 4D Nanoscope. His current research interest focuses, as always, on medical imaging, but as well on image and audio processing in the digital humanities. And about this, he will be talking, and interpretable machine learning. So thank you very much, Andreas, for accepting the invitation, and the floor is yours.
Yeah, thank you very much for the introduction. So, and this is also a great opportunity to highlight a few things of the works that you're doing in digital humanities. So as you just said, about 70% of my lab is actually focusing on medical imaging, but of course the methods go along with the demands in digital humanities. So I found that very interesting. So because the university I'm at, Friedrich University, is actually a full spectrum university. So we also have a lot of researchers in humanities, and it's always a great pleasure to collaborate with them. And this is also why why I got interest in the European Time Machine project, and why we still try to contribute to that project. And I think the vision is just really very convincing, and this is why I want to present first of all the vision and also some minor building blocks towards this is a gigantic idea.
Andreas, we hear you twice. We hear you and then hear you again.
Really? That's interesting. Didn't happen before. But
you have two microphones.
Does that fix the problem? Does that fix the problem?
Yeah, continue speaking.
Okay, so I just muted my speakers, so I won't be able to hear you, but I hope the problem is now.
Yes, I think it's better, let's say.
All right, then I try to continue with that, or I can also switch the microphone.
Switch the microphone, please, because
Yeah, this one, is this one better? This is the internal.
Yes, this is better. This is better.
Okay, good. I have this very nice microphone, but sometimes it doesn't work as expected. Okay, if that microphone is better, then I'll continue with that. All right, so let's talk a bit about the vision. So I'm a member of the steering committee of the European Time Machine project. Right now, this is an European association that is actually based in Austria. We attempted to go for a European flagship project. We were pretty far in the competition among the final 6, but then unfortunately within Horizon Europe, the flagship competition was stopped, and the last remaining 6 projects simply did not get to submit their proposals, but instead they were then asked to help to support developing guidelines for the European Commission on how to select funding. So yeah, this is why the big dream of building a flagship project towards the European Time Machine did not become funded in the way we wanted, but we're still working towards this. And yeah, the main idea is that we want to be able to unlock the archives of the European past, to make them accessible and to be able to use them at large scale. And this is the European Time Machine project. So the basic initiation actually happened in a European project that was led by Frederick Kaplan together with the Venice State Archives, and they had the ambitious goal that they wanted to digitize or start digitizing the entire archive. And this is huge amounts of historical data that would be accessible if you could digitize them. You can see here some scenes from the state archives. There's a total of 80 kilometers of shelves that would need to be digitized in order to unlock them. And you see what large language models are being able to do now, and they're essentially built with the entire internet. Now imagine what you could build if you had access to all this data, to 1,000 years of historical data only at one place here. Now imagine this scaled up to a European scale. That would be tremendous. And of course, it's also multimodal data, it's maps, it's all kinds of different data sources. and they're currently in the Venice State Archives, in archives all across Europe, and they are essentially inaccessible to the big data AI methods. And this was the unifying goal that was behind, or is behind, the European Time Machine project, the big data of the past. And you can see the huge problem that we have is, if you go back in time, the amount of digital data is really, really scarce. In our nowadays modern society, we have tons of digital data, but the more you go back to the past, you can see that the amount of digital data is not accessible, it's not there, it's not scanned, and it's very scarce. And one idea that the European Time Machine project is following is that you could increase the digital information, not just by digitization, but also by additional simulation engines. And if you look at present day developments in AI, these image generation, text generation, and so on, these tools will be vital in order to get a better understanding of the past as well. So here you can see a mock-up. This is a reconstruction of Venice, and it's actually fused with cadastre maps where you can see the different businesses. And this is a reconstruction of Venice at the time, essentially originating from a map, and this is merged with 3D scans of modern day buildings. And you can see that the facades, for example, here, they're intentionally left blank because we don't know, it's just a gray face here. We don't know how the surface, how the paint was done at the time. So we leave that away, but you can already get some understanding of how the city was looking like in the past. And you can also then see that the city has different development scales. Yeah, so it's not just that all of the buildings as they're there today, they haven't all been part of the past. So they have been built over the centuries. So you can see this is just one snapshot of the history of Venice, but actually you would need something like a time slider where you could then see how buildings emerged when they were constructed, how businesses actually have started, how they vanish again, and all of this information somehow needs to be accessed and visualized. And this could be one pathway of how to actually accomplish such a goal. Well, this is a huge European effort. Across Europe, there are many, many different groups that have been joining these efforts. So there's Amsterdam Time Machine, Antwerp Time Machine. Of course, the Venice Time Machine is still there. And as you can see here, there's also a project, the Nuremberg Time Machine, where we're currently trying to get additional funding and actually to realize that one. But teams all over Europe have been inspired by this vision, and they are now trying to collaborate and bring forward the idea of making the past accessible. Now, after seeing this huge scale effort, I also have to tell you that many of these things here, they exist as ideas. Some of them have prototypes, some of them just exist on paper or on this PowerPoint. So let's talk a bit about the things that actually exist. And this is where I want to highlight some contributions actually from my institute and from the work of our Digital Humanities group. And I tried, of course, to keep them short because I want to give you an overview about the different things that we're doing. And then I want to go back to the vision of the time machine and see how these things may really go together and help us to access and unlock the powers and the knowledge of the past. Well, one thing that you could start with, in order to unlock the past, you will need to digitize. And one idea that already came up in the Venice Time Machine is that you could digitize books by using X-rays. And of course, as we are working with medical scanners as well, I was very intrigued by this and independently developed with my former PhD student, Daniel Stromer, also the idea of book CT. So this has been developed independently across several places of Europe. And then when they were actually published, we realized that also Venice Time Machine people have been working on this. And this was the first contact point actually of my group with Frederick Kaplan's group when we realized that they have been working on the same topics. Well, what drove us is that you see that there's, archives, they're not always accessible, but some of these books, I mean, even if you would like to scan them, some of them are in so bad shape, like here on the right-hand side, that if you open them, just the letters fall off. And they would be damaged simply by opening them. So this is a manuscript from St. Omer on the right-hand side. On the left-hand side, you see some example from Germany. Actually, there was a huge fire in 2004 in the Duchess Anna Amalia library, and this mutilated many of the books there such that they are really difficult to work with, but still they contain unique knowledge and we would like to access that. So the idea we came up with is, if you look at many of the historic inks, they contain metallic particles. On the right-hand side, you see some example of iron gel ink and the corresponding X-ray absorption spectrum, and on the left-hand side, malachite. So these are like two inks. Iron gel ink is probably the most predominant one, and about 90% of historical documents have been created in iron gel ink. The Declaration of Independence, for example, is also written in iron gel ink. It contains iron particles, and this is something that's very good for us because with an X-ray, you see very high absorption of X-ray in iron, but of course not in the paper. So you could take the entire book without opening it, put it on a turntable, you see on the right-hand side, scan it with an X-ray detector. So take X-ray projections from all sides, so you turn it. This is happening in a machine like the one you see on the left-hand side. This is actually the used CT system of our material sciences group here at the University of Erlangen. And we scanned a book and tried to reconstruct it. And the first thing that you realize is, okay, you see some letters. So it works, we can really see contrast. But then you realize, okay, these CT systems, they assume a perfect Cartesian grid on which they reconstruct the volumetric information. So you cannot just see individual letters, but you also see that some of the pages, they're overlapping, yeah? Because if you look then from a view that is 90 degrees turned, these pages here, they're not perfectly aligned with the Cartesian grid, they're curved, right? Because this is a book, right? So it's not perfectly flat as you would like to have it, and it will be impossible to have it perfectly flat. So what you need to do is, from the center here to the right-hand side, you need to segment every individual page. So first the 3D scan, then you segment the pages, and if you have a page segmentation, then you can virtually flatten it. So you take these virtual pages, you see that the ink kind of is sinking into the page, and because the page also absorbs some of the ink. That's good for us because that gives more contrast. And then we virtually flatten the page, and it's still volumetric, and we then boil it down into a 2D image. And with this 2D image, then we have page by page every information of the book. So you see here some example results. On the top row, you see different photographs of the page. So this is a facsimile, on the left-hand side malachite, center iron gel ink, and the right-hand side we had iron gel ink and added a little tiny bit of additional iron in order to increase the contrast. And you can see here in the malachite, it's a bit difficult, but you can already see the contrast. The iron gel ink is very well suited, and with, of course, increased contrast, you get really, really good scanning results. So these are automatically extracted pages from the book that you see here on the left-hand side. Of course, this is only the first attempt here. We have a current running DFG project where we now optimize the scan parameters in order to reduce the dose, because we don't want to damage the historical books, but at the same time increase the contrast. And this is a current running project, and we hope that at the end of the project we will have essentially a kind of manual that tells you which document to scan with what kind of scanner settings. Now, this of course not just works for European books. Daniel actually presented this on a conference in China, the first results, and then he actually got one of the Asian books. So this is a bamboo scroll that is also kind of problematic. You find still ancient bamboo scrolls that have then to be cleaned and made accessible in very, very expensive ways. And he was thinking, maybe I can also use this technology for scrolls, and actually it works. So you can see here a first scan of a bamboo scroll, the one you've just seen, and this has been embedded in soil and water, and then the soil scroll has been scanned. You can see some of the letters here, but Of course, it's not perfect. So in the next step, he performed a virtual cleaning. He essentially detected each individual bamboo strip. And after detecting the strip, you can remove the soil. And this is now the virtually cleaned bamboo scroll on the right-hand side. On the left-hand side, the original scan. And once you have the individual strips, then you can also reconstruct them on a 2D plane, order them. And here you see before of the experiment, the photography before soiling on the left-hand side, and on the right-hand side, the unwrapped X-ray CT scroll that emerged from the scan after the soiling and the scanning. So this is also a promising technology that may even go beyond a European scale. Another type of tools that we've been working on, my colleague Vincent Christline has been working on writer identification. And you see there will be now many similarities to the previous presentation that we've shown, because we use very similar technology, but of course onto a very different topic. And the topic we were interested in is identifying a writer. And this is very interesting for historical texts as well, because if you have handwritten documents, you may want to identify who has written this text. And there's plenty of anonymous writers. And if you would be able to analyze on a large scale who has written which part of a document, then you can also analyze like working structures in different institutes producing those texts and so on. So this is a very intriguing technology. We started off with modern day analysis that you see here, then also not just with the alphabet, but also in Greek letters, and try to identify the writer. So very important is that we're not developing features that only work for a certain handwritten alphabet, but really recognizes the handwriting, like you would do in a forensic screening. There you are also interested in finding features and descriptors that don't associate with a single letter, but rather the curvature of certain parts of the letters, such that you're able to identify a certain person writing. And yeah, you can see here the approach. Of course, this also works with historical data. So here you see two historical examples, and the approach is very similar. We sample from the writing, then do some features extraction in the beginning. Vincent was working with classical features, but then very quickly he has seen that representation learning is a much better approach. And he has been working on this since 2013 and improving his writer recognition engine all along. And you can see that over the years in different competitions, the system have been improved quite a bit. Mean average precision is going up over the years. And by now we have a performance where we actually have writer identification rates on modern day scripts that are way above in the 90s, and also on historical data we have made quite some progress, where we can now see that it's actually a tool that will be usable for the humanities. Of course, there are still some challenges that Vincent is working on. You know, with historical text, you sometimes have problems with the scan quality. Sometimes you have the back of the page shining through. That is a problem for the binarization. And then something that also happens in historical writing is, you see here on the right-hand side, the writing of the same person, but 10 years apart. And here it's very difficult to say, is it really the same person? Is there something wrong in the labeling, or has the writing evolved over time? Yeah. So is this a different way of writing, or is it a different person writing the same script? So this is something where we really go into the annotation, and then these are also questions that we have to solve with the historians, because they also have only certain access to the data. They have to believe their sources, and sometimes sources are not reliable, and you have to actually go down. And this is very interesting. It's very much like analyzing a crime scene. Yeah, you have to look at all the evidence, and then you have to see where we can get new conclusions on the history. All right, handwriting is one issue, but one of the side effects is if you have a model that is actually able to characterize a person, the same model can also be used to imitate the handwriting of a person. And you see here an input text on the top hand side, and then this has been adapted to another person's writing for 2 times, and this way you can even imitate another person's writing, and not just the actual writing itself, but also the way it is produced. So this here is a recurrent model, and this recurrent model is able to imitate really the actual writing process. So in all of these tools that we develop actually to gain new insights, you potentially can also reuse them for very different purposes. And this is of course also something that we're discussing with AI ethicists on the potential side effects that our technologies have, and that they could, for example, be used for historical forgery. So in today's analysis and with today's tools, you have to be very, very careful that the sources that you're accessing, that you can actually trust them. And of course, this is always true for historical sources as well, because there have been plenty of people all across history that tried to write history in favor of their own side. And of course, with tools like this, this could even be done in a large scale in today's historical documents. All right. Of course, handwritten text is one way to go, but the prints are also a certain kind of historical source that is very important for us. And this is work of Matthias Soré. You can see him here on the top left. And he has been working on text recognition. And in order to build better text recognition engines, it would be tremendously useful to actually identify the types. And he has been working with the type repetitorium from the State Library of Berlin. And with them together, he then was building specific models to detect the type. And here are some examples: Antica and italic types that have been used, but there's also textura or rotunda. And you can see that the types are very different. And you build an OCR model for modern day text, they will fail on these types. So you probably have to have a kind of type detector in there in order to have the optimal OCR model for that specific text. So he started off with a CNN deep learning type of approach in order to classify the types. And yeah, then you have pages like this one. And you can see here that this is actually mixing types. So this is actually mixing Antica and italic. And you can see in the classifier output, it has a confidence or a score of 0.7 for Antica and a score of 0.4 for italic. So this is kind of a problem. But actually, after we built the classifier, we can also make use of it in order to localize the type on the text. And he has been exploring this using the GradCam type of visualization techniques. And you can see the Antica response is very high, and these two fragments of the text, and the italic one is very high here. So we can use this text in order to see which OCR engine to use on what part of the page. Also, you can cluster pages. And this is quite interesting because his classification technique, he can also use them in the very last layers and take this representation. And as in the previous talk, we have the same effect, that representations that are trained on the system, representation of the same type, they lie really close to each other. So this is a kind of a visualization of the supervised approach, but now we can also use that and use it for clustering of new data. And this is now unseen data that we haven't been processing. And if we then go back and analyze this dimensionality reduction, you can see that this is Fraktur, this is Bastarda, Textura Rotunda. So we can find clusters also in new pages. And this then also can help us to actually analyze data. We have a nice cluster for Antica. And then we could also find new clusters that haven't been trained with, and they also get projected here. And we found empty pages actually in really large scale, and book covers. And the book covers, they get representations that are unlike the ones that you would see in a classical text page. So after seeing that what we can do with printed text, I would also like to spend some time on paintings. And analyzing paintings and prints is of course also very important if you want to get access understanding of the past. And here this was a project with the German National Museum in Nuremberg, where we're analyzing the paintings and prints of Martin Luther. And we wanted to find similarities, and we wanted to actually get an understanding on how Martin Luther has been portrayed over his lifetime, and also realize whether the way how he has been portrayed has changed over history. And there are certain kind of portraits that have been used at later stages, and that have been also then used in the translations of the Bible, and they had a certain, let's say, political rationale, and therefore certain kind of displays of Martin Luther have been used for specific purposes. Also, we wanted to understand the serial production. So at some time it was very popular to buy a painting of Martin Luther and then actually put it, you know, in for display in order to impress potential guests if you're a wealthy person. And we can also see that some of these paintings have striking similarity. So we were also interested in the analysis whether people have been using templates in order to generate those images. In order to do so, you have to be able to, you know, bring things into this joint framework. So we've been working on image registration between portraits and prints. You know, we have mixed types. So maybe this was inspired from a different source in order to find this out. And the appearance here is very, very different between prints and portraits, for example. And then also we did similarity analysis in order to find repeating elements, like here, that could be related to templates, or repeating motifs where people have been taking inspiration from the different sources. And this is work here by Aline Sindel, by the way. And in the first approaches, she was working with face detection and analysis, adopted this to historical paintings for portraits, and then was working on registering them into a joint frame. And here you see two paintings of Martin Luther, and if you bring them into the same frame of coordinate, you see that the similarity is quite striking. Yeah, you see the blend over from one to the other picture, and here we are really working with the art historians, and there is a certain chance that the two paintings have been produced with a similar template, or that actually one was used as a template for the other, because here you see the nose, the eyes, the positioning, the orientation in 3D space. They are so similar that it's rather unlikely that the two have been generated completely independently. Then, of course, we were interested in analyzing prints, and yeah, this is a problem. Is of course prints, they change over time. First of all, the printing plates, they wear off. The more you use them, small parts break out. And then also sometimes you apply them with different pressure and different distribution of inks, which makes the appearance so very, very different. And we were registering them into the same frame of coordinate, and then you can analyze the tiny differences between the two different prints in detail. Then, of course, it is a kind of challenge to bring prints and paints together, right? They have the same motif, but the appearance is very, very different. And for this, actually, Aline created not just an edge detector, but a deep neural network that she called Art to Contour, that would take either prints or paintings and extract the dominant contours and then use them for registration, because based on this, you can really bring two very, very different kind of representations, kind of appearances into the same frame of coordinate. And Art to Contour you can actually get from us, and if you want to try it, it's very, very interesting if you have problems where you want to compare prints and paints. So here you can see just a piecewise blend from a print to a painting, and you can see that also the alignment works quite well between these two different domains. Yeah, one last thing where we looked at is multimodal imaging in paintings, and here we have the problem that sometimes, you know, you take visual light photography and infrared reflectography, and the scaling may be different in the different modalities, and you would like to align them with the same frame of reference. And sometimes it's very hard, because if you look at an image like this one here, there's essentially only the face where you get good textural information, and there's large portions here where you don't have good texture. But what you can use is the craquelé. Yeah, here this actually the where, how the actual underlying canvas has changed over time, and they have this tiny spider web type of structure, and it's the same over all of the modalities. So Aline created a deep neural net she called craquelé net, and it would extract key points of this tiny web-like structure all across the image, and this allows a very, very high quality overlay even in areas where you miss classical picture and key point information. And this way we were able to do very, very good alignments between the different modalities. So here you can see some results, and again I have a blending animation here to go from one modality to the other, so from X-ray to the actual photograph, and you can see that the alignment works at a very, very high accuracy. Okay, so now we talked about tools, mostly digitization, analysis. Most of this was using classical computer vision methods, but it's not where I want to stop. And I want to highlight, actually Pratmesh defended his PhD thesis yesterday, and he was trying to go one step further and not just, you know, taking a look at different computer vision methods and retrieval, but really put in a theory of how to understand art and how to analyze art into a computer algorithm. And he was working with art historian images and also archaeological images and trying to analyze scenes. And yeah, so of course you do classical pose estimation type of approaches where you can then detect persons, first bounding boxes, then key points, and then fit a skeleton, right? This would be a classical computer vision type of approach for pose estimation, and he did tremendous good work on bringing this to an art history and archaeological context, which of course involved building your own database. He has published a public database where you can now have ground truth and use that from, you know, large-scale pose extraction databases, train your system there and transfer it to the art domain, which is useful. But he didn't stop there. He was actually also implementing a theory actually by Imdahl, which is an art historian theory, and he was developing a theory how to interpret images. And he essentially defined pose and action lines in an image that would characterize where the action is taking part, where the important part of the action is, and how these lines are actually putting the faces and the poses of the different persons together. And based on this very abstract way, using just lines in the image over groups of persons, you can find similarities also across images that just show the same motive, but not really on a visual scale, but on a very abstract scale. So you can see here that you know, persons are facing each other, and this way you can create an abstract description of what is happening in the scene using these kind of action lines. And yeah, Pratmesh actually created an automated version of Imdahl's way of analyzing scenes, and he would of course detect then poses is the first step, but then he would detect those pose lines and action lines, and with those you're then able to describe abstract scenes, and you can use that, for example, then in retrieval tasks. And here you get very independent of the actual style, but you're only interested in the content and how abstract groups of persons are reacting to each other, and you can find then similarities of groups of persons across many different domains. And you can see here, this goes way beyond just pose recognition, but really an abstract description of the scene. And Pratmesh succeeded in implementing an art historian approach into a computer program. And I'm very proud of this work, because it's the first time that I've seen, at least, that somebody really takes a theory from art history and makes a computer program out of it and makes it usable at large scale across, you know, the boundaries of art, photorealistic images, and classical archaeology. And I'm really thrilled by this, and I hope this kind of tool can help art historians also in a kind of, he has also created a website where you can then upload an image, the IMDAL analysis is taking place, and then uses this for image retrieval across a large database of domain. All right, so you see, we try to develop
3 minutes.
We try to develop tools for the future of digital humanities or computational humanities, but how can these things, you know, be integrated? And I've been thinking about this a lot because, of course, we've been involved in how to integrate this in Time Machine, right? If you go back to the Time Machine implementation plan, you can find here that all I've been talking about is essentially different document processors, iconography processors, then, of course, maps. I haven't talked about this, but you could have geohistory processors, 3D object processors, and you can bring that into a joint representation. As we've just seen in the previous talk, yeah, you can, of course, map this somehow into an abstract, you know, multi-dimensional, universal representation space. This is one way to go. And then we end up with something that is very similar to what we see now in ChatGPT and, you know, these large foundational models. But something that's missing is the logic. And this is why Time Machine wanted to embed a logic and inference engine into the simulation engine, the representation engine, and make it intercompatible. And I think this is the future to go. And if you think this is too abstract, we don't know how to actually implement that, let me give you an example that is also very recent from early this year. You see with ChatGPT, things have been changing quite a few, and human-computer interaction will change in the next few years dramatically. But you know, ChatGPT, large language models, they are prone to hallucinating all kinds of things. And this is not very useful if you want to use it for a scientific purpose, right? But one noteworthy development that I want to show here is actually the integration of tools into ChatGPT. And this is an example that uses Wolfram Alpha as an underlying engine. So you can ask ChatGPT, the new version, by the way, you have to pay for this for the plugins. How far is it from Chicago to Tokyo? And it has this plugin architecture, and then it says, okay, this is something I could ask Wolfram. And then it uses the Wolfram engine to actually get the distance from Chicago to Tokyo on a geodesic. Yeah? So it would, if you travel by aircraft, it would take you about 11 hours and 30 minutes. And then you can ask stuff like show the path, and it uses again the Wolfram engine to render this map here, and you can really see it's not using a straight line across a map, but it's following the geodesic. It's because the Wolfram engine can do it, and this is a symbolic engine, like the ones you've just seen in the Time Machine chart here. And the way how it interacts is ChatGPT, large language models, are very good with text, and it can convert natural language to code. And what it does, it takes the natural language query, translates it into Wolfram language, feds the Wolfram language code into the engine, gets code back, and translates it back to natural language. So this way, you can now suddenly interact a broad variety of tools, even without knowing that these tools exist. It translates it into the right configuration, runs the respective query on the tool, and brings it back in natural language. And you can even see the code that was generated by ChatGPT and fed to the engine. And of course, the most well-known thing is that all these large language models, they suck at math and it's completely unreliable. But if you use Wolfram, you can suddenly compute the integral because Wolfram can do it in a symbolic way. And you cannot just get an accurate solution for computing an integral. So suddenly ChatGPT has superpowers in math, and it can also plot it. Now, how about we would generate not just a large language model of all the scanned history of the path, but also combine it in such a way with all the different tools you've seen today and all the different tools that people are developing all across Europe, all across the world, in order to unlock the information that we have in the past. And this is where I want to stop my presentation. I'm running out of time anyway. I hope it wasn't too boring, but I hope that these ideas may convince you that following this idea of a European time machine project, making things interoperable and connecting all the tiny developments we have all over Europe that do tremendously good work, but are seemingly incompatible, that it's not a lost cause, and there's actually ideas around how to bring them together into a joint system. Thank you very much for your attention.
So thank you very much, Andreas. Yeah, you showed quite some things. I have a couple of questions as well, but let's see if there are questions from the audience. Normally they come just with time. I repeat that you have to write down the questions on the right hand side under domande or questions. Okay, let's see what I have here. Probably this is for Giuseppe. It says, very interesting. I suppose that visual searching applied to cultural heritage is very useful also for police departments who are searching for stolen objects, isn't it? So probably she wrote it before you said it, because you said that, right?
Exactly.
You were mentioning Carabinieri, which is a part of the army, but Polizia, yeah, it's a similar body.
We're trying to do with the, not with the police, but with the Carabinieri, which is a different group of related to security in Italy.
Yes. Okay. So actually, you responded without knowing. All right. Then there is a question from Paola Letardi. I would like to know if there is any project or application to use these techniques for maintenance. I mean, to check after restoration and identify critical signs which recommend maintenance action. I don't know to whom she's posing the question, maybe to both of you. So for maintenance, check after restoration, identify critical sign which recommend maintenance. Who do you think is she addressing?
I can try to answer from my part, but I'm not sure that it satisfies completely the request. What I can imagine is the following: if you have a picture of, for instance, a painting, but the same kind of a statue or to a building, but if you have a picture before the restoration, and then you take a picture also after the work of art has been restored, you can compare them to check the differences. For instance, this is what I can imagine. So just to check that the original version was not altered somehow, and that the restoration is somehow compatible with the original version. This is what I can imagine to the answer, but probably I need additional information. I don't know, Andreas, do you have any additional clue?
I think that's an important topic, and I think that we also should be able to track, changes over time, and in particular in things that you've been showing, you get recent updates all the time. Yeah, if you use that in tourism, people take pictures of noteworthy landmarks all the time, and of course, I think you could use that first of all for maintenance, detect when maintenance is necessary. You can also, I mean, if you think of the time travel, the things that are really traveling the time are the object, right? So the people, they live and die, yeah? So they only have a very short fraction of history that they actually experience. But the objects and the buildings, they change over time, and they have, of course, tremendous changes over time. Buildings get expanded, historical landmarks get damaged. We see conflict all over the world sparking again, and we see historical landmarks completely perishing. And if we have digital tools, at least to do 3D scans of noteworthy sites, then after the conflicts, we might be able to restore them in the ideal shape. So I think that's a very, very important comment, and I think technology can be used for exact those purposes.
Yeah. Okay. So yeah, so more than after a restoration, yeah, maybe also after restoration, but anyway, you can see if something changed so that it needs restoration, let's say. That change after a restoration or after a war, let's say, that's not important.
Probably, Andrea was saying, probably you can monitor day by day the evolution of the alteration that occur in a work of art, and at a certain point you decide, okay, I need to intervene somehow.
Right. Okay, then we have Maria Pia Casaletto for Giuseppe. Concerning your collaboration with Carabinieri, the app you referred was ITPC. So it's just if yes, does it have an open access or it requires some permission to be downloaded? Thank you.
Yeah, actually, I think ITPC is the previous version that was used by the Carabinieri, and as far as I know, now it is no longer working. The new app, as far as I know, it is not still released because we are working on it. By the way, we are working on the tool behind the scenes. So we are working on techniques for matching picture with the database of the Carabinieri. Then the app will be developed by someone else. But for sure, it is not yet. I mean, the ITPC version is the old one. The new one is being developed, so not yet ready. I don't know what would be the policy. I mean, if the Carabinieri will give access to the application to everybody, or if it will be maintained and accessible just upon request. This, I don't know, should be asked to the Carabinieri themselves.
All right. I have a question for Andreas. So the thing that struck me was your analysis or your scanning of books, of closed books with X-rays. So are there limits there? I mean, how many pages or how, let's say, separated must the pages be such that you can use something like this? I mean, do you need to have pages which are very thick and distanced, or so? Did you try to analyze? So until which point you can use something like that on a closed book?
Okay, so we started, of course, with thicker pages, but so I think we had something like 0.1 millimeter thick pages, which is kind of okay. But the scanning resolution, we can go down to something like 20 microns, which in this type of page we would have 5 voxels, which is kind of decent. We can also go thinner, but if you have to reduce the resolution, you probably have to increase dose. And the thinner the pages are, the more X-ray dose you have to use to get a good resolution. And that goes, unfortunately, with a factor of 16. So at some point you have to check whether you're depositing so much dose that you would actually start a change, a deterioration of the paper, and you heat the material up. But with the present scanning, we are far away from that. So I think it should be fine with classical pages. One clear limitation is what I've shown is not working on modern day books, because the modern day ink is not using any iron particles, but they are built from cellulose, and this has almost the same absorption as the page. So we have no chance in scanning a modern day book. So it doesn't work. There's other ways how to do it. We're looking into this very good work at MIT, where they have been looking into terahertz. We've been also exploring this technology. This could potentially work also on present day ink, but there we have a problem with the thickness. So we couldn't scan things that had more like 10, 15 pages. Okay. So
and until when were those inks used? So when was there the change to the modern inks?
I think that happened around the 1850s, 1900s. where they were using cellulose-based inks. Before 1850, the iron gel type of inks have been used quite frequently, in particular because they have they're document proof. So they keep very well over history, over time, and people like that because they knew that if you're creating a document with that type of ink, it will preserve history. So important documents that were intended to last for centuries are very, like Declaration of Independence, for example, are likely to be generated with iron gel inks.
I see. So I mean, I'm not clearly knowledgeable in this field, but whenever I saw in, I don't know, online or in television projects about the digitization of documents, I always saw them scanning page by page, so with visual methods. How ready for application is this other method? Because it means it's a game what people call a game changer, I guess. So it's something different and very much different and more useful, I guess.
Yeah, one thing that we're not good at is color, because we can detect ink. So for text, it's good, but as soon as you have nice, colorful, you know, additional paintings on the text, which happens quite frequently, we are technically, it could be possible to differentiate different materials, but they have to have a different X-ray absorption spectrum, and colors is a huge problem right now. So this is one way where we have trouble. The other thing is scan time. This is not really quick. So for the scans that we've been doing here, we partially had scan times that were in the range of hours. So it depends on the dose settings. If you want to do a low dose scan, it then potentially also takes longer. So there's a lot of things that we have to keep in mind. But of course, we know you can build scanners dedicated to a specific purpose such that you're very quick. So in the medical domain, we can scan, you know, at 0.5 millimeter scale from head to toe a person within 12 seconds. So if you have an injury and you have a fracture of the spine, you don't know where it's located, you have a full body CT scan, can be done within 12 seconds. So there's a lot of ways how to build these systems, how to optimize them for a specific purpose, how to build tubes that are dedicated to a specific purpose in order to speed up the scanning. But I think one major problem is that the technology is much more expensive than a camera. And if you can scan, now there's automatic page turning and things like that, it's pretty fast. Most documents are suited for page turning, they get color, the machines are out there, and they're in, I mean, such a page turning system is maybe in the range of 50,000 euros. If you buy an X-ray tube, you spend for the tube alone between 50,000 to 100,000, depending on the type of tube. Then you'd spend another 50,000 on the detector. So if you want to build these systems, you would be in the ballpark of 200,000 and more euro. Dedicated systems, if you don't have large numbers of systems manufactured, you may end up with a 500,000 to 1 million for one unit. And then, yeah, you know, the main customers will be public libraries. So we don't expect many units to be sold there. It's a limited market. So there's all kinds of problems in market analysis.
But this page turner that you were speaking of, can they turn as well frail pages of historical documents? And I mean, you were speaking of the documents from the year 1000 to the year 2000. So medieval documents.
Yeah, they can have pretty large volumes that maybe 40 by 40 centimeters in page dimension. It will fit the system. They are rather gentle with the manuscripts, so they can be used at least for, I'd say, at least 300-400-year-old documents. They are usable. I've seen things being scanned with that. But if you go back in time, then handling the document also gets very, very expensive. And I mean, if you want to 3D scan a real historical document, you have to insure it. It has to be transported to the scanner and so on. It makes the whole process very expensive. So maybe it's easier to bring the scanner to the actual site than the document to the scanner.
Right. Okay. Great. So you will go on with the scanning of the Venice Library or whatever else if you get a European, a big project, a bit publicly funded project, right?
Yes,
okay.
That's the intention.
Fantastic. Okay, so I had a question for, nobody's asking questions, so I go on with mine. For Giuseppe, you showed a lot of this cell phone point and click, so photo taking and getting the result about what you are looking at. These descriptions, are they taken from the web, from Wikipedia, or do you have to prepare them before in Tuscany, in Pisa? So do you have to make a work of ordering things?
It depends on the specific application. I presented two examples of applications that we built. One was the Pinacoteca di Brera. Pinacoteca di Brera has all description of the work of art publicly available. So we directly connected to the description already available. But okay, nobody prevents you from preparing specific descriptions to be associated with the recognition. The recognition of the image is just a trigger to access some information, which can be information already available online or information prepared on purpose. For instance, in the first experience that we had, the first one that I also described, the project Visit to Tuscany in 2009, at that time, the descriptions of the monuments in Tuscany were positively prepared by one of the partners of the project. But consider that at that time, open available information was not so huge like today. As I said, also smartphones were not so common. We typically used old style phone. We're just able to make call and send texts, but not smart screen, etc., etc. So at that time we built everything from scratch. Nowadays life is much easier.
Okay, and what do you get from you showed a fragment of an epigraphy where you said you cannot search for words because were just a couple of broken letters. What do you get in a case like that? Actually,
I mean, the epigraphy scenario is quite peculiar because all known epigraphs have been studied in details by several archaeologists and art historians. So every epigraph has plenty of descriptions. And typically there are also several images for that epigraphs. So the job of the Eagle project was to put together all that information in one single repository. So images and also metadata generated by the domain experts, by the archaeologists. Okay. And by using let me also say that in many cases, the text of the epigraphs is in Latin or Greek. So you can search by using the text just if you are knowledgeable of those languages. We found that for, let's say, for the general public, it was much easier just to point the mobile phone toward the epigraph and use the shape of the epigraph to go to the information associated with it. Also in that case, the description were not description already available online, but were description maintained and curated by the experts. The task of the project was to put everything together. also publish everything on Europeana, which is the European search engine for cultural heritage, said in a few words. And by using the mobile app, is it possible to access this information starting from the picture of the epigraph itself?
Okay. So personally, I would have a last question for Andreas. I see that Vincenzo is back, but I don't know if he has questions, but probably not, because he was doing something else. Yes. So for Andreas, I didn't really catch what you wanted to say with your final slides when you showed the ChatGPT and with the Wolfram engine. What did you want to say related to the cultural heritage stuff that you've shown before?
Well, on the first hand, I wanted to link, we have all these developments across Europe, and it's, not just my group, but there's really many groups working on similar topics. And a question is how to bring those tools together, right? And I think with foundation models, we have now very nice tools of converting from one representation into another. And I think these and you also have to think about how to interact with such systems. And if you have very specialized tools, it may be very difficult to interact with them. And the aim that we have is to enable humanities scholars to interact with all of these tools. And I think the interface that you can have with a human-centered large language model is something that comes in very natural, and it's very close to the work how humanities scholars also work. If you look at the research, I mean, of course, it's text and it's supplemented with figures to demonstrate things, but yeah, you want to be able to represent things also in text and link these things together. And then you also want to not just generate text, but you want to link that to a specific source. And the integration of such tools would allow that. So I think that is a future perspective that we could go, and that doesn't require to have everybody following exactly the same design guidelines, because that will be very, very difficult to implement in such a heterogeneous field. As research in general, it also, I mean, if you had a flagship, then you could potentially work on these standards and give out coding guidelines and support implementation of APIs and so on. But we won't have that. So you have to find a different way to make things connect. And I thought that is a very elegant idea how you could interoperate.
Okay, now I get it. Yeah, thank you. Yeah. Okay. Yes. So the sense of this. First of all, I forgot to tell everybody that, as usual, the slides will be sent after the seminar. Now I have both slides from both speakers. The one from Giuseppe AMATO, you had the possibility to download it directly from the right. I also forgot to mention that. But anyway, in between I got the slides from Andreas as well. So after the seminar, I will send to everybody who registered, not only the ones who attended, but the one who registered, the slides as always. And soon, in the next days, we'll also have the registration. Okay, so but the sense of these meetings is also to try to possibly establish new connections between the speakers themselves and the audience. So when I send the slides, I also CC the speakers, and so you have the possibility to contact them directly. As always, I ask to give me a feedback if something comes out of these connections established, such that we know that we have been useful also in a year or something. Exactly. I guess that I mean, this series is about AI, so the experts that we asked to give the presentations are from this sector, from the AI sector, and not from the application domain sector normally. But I think that especially today we'll have several persons who attended who are from the cultural heritage domain. So CNR has a department, a cultural heritage department. So yeah, that would be, I would be happy to hear about collaborations between AI specialists that we have today as speakers and the domain specialists that are listening. Okay, so having said that, soon the announcement of the next webinar will come out, so stay tuned. Please, I ask it especially to our German speakers, as always, because we have relatively few German in the audience. So please diffuse the information as much as you can in your networks. I will keep you in all the next announcements, and yeah, I would be happy to have even more German. It doesn't have to be strictly from your institution, so just diffuse them in Germany to whoever may be interested. Okay, from my side is I'm finished. I don't know if Vincenzo wants to say a final word.
So I just wanted to apologize again for having this this short notice video conference that messed up my whole morning, so including this conference. So apologies again to the speakers, and I'm sure I glimpsed that I have missed quite interesting presentations. So anyway, yeah, it was anyway, it was interesting to see at least a little of it, and it was a pleasure again to take part in it.
Okay, so thank you very much again, and to the speakers and to the audience, and yeah, see you next time.
See you next time, and thanks for inviting me to this.
See you next time.
Bye-bye.
Bye-bye.
Bye.